Today we did product rule and quotient rule. Both of these rules are used when we have two functions within one function. Product rule is used when we have two functions that are multiplied to each other, and the quotient rule is used when we have two functions that are being divided. So within the product rule, if I have a function f of x which equal to a function small f of x times gf of x, to find the derivative using the product rule, f dash of x equals function f of x times the derivative g of x plus the function g of x times the derivative f of x. Also, we can write this in another manner. If y equals u times v, where u and v are functions of x, then dy dx equals u times dv dx plus v times du dx. So this is exactly the same as we did in the one with f of x. It's just a different manner of writing things down. Also, we can write this as y dash equals u times v dash plus v times u dash. Alright, let's do an example where we can demonstrate this. So from the exercise 9F on your page in the textbook 320, example 1 from the question 1a. When we have y equals 2x squared plus 6 times 2x cubed plus 1, we can solve this by let u equal 2x squared plus 6 and also v equals 2x cubed plus 1. First we need to find du dx and then dv dx. So du dx, which is finding a derivative of u, which is 2 times 2 is 4x, and finding a derivative of function v, dv dx equals 2 times 3 is 6, x squared. So using the product rule, dy dx equals u dv over dx plus v times du dx. We have our u, we have our du dx, we have our v, and we have our dv dx. Therefore, u is 2x squared plus 6. dv dx is 6x squared plus v is 2x cubed plus 1, and du dx is 4x. And when we solve this, we get 12 x to the power 4 plus 36 x squared plus 8 x to the power 4 plus 4x, and rearranging all this, 12x to the power 4 plus 8x to the power 4 is 20x to the power 4 plus 36x squared plus 4x. And this example demonstrates the product rule. Alright, so as previously stated, quotient rule is also used when we have two functions within one function. The difference between a product rule and quotient rule is that product rule is used when two functions are multiplied to each other, whereas in quotient rule we use this when two functions are divided to each other. So when we have a function f of x equals f of x divided by g of x, and really important part here is that g of x does not equal to 0. Then our derivative f of x equals to g of x times f dash of x minus f of x times g dash of x divided by g x squared. So this is a very important rule. Make sure you highlight it. So let's have a look if we use different notation. So when y equals u divided by v, v does not equal to 0, and where u and v are functions of f, functions of x rather, then we get that dy dx equals v times du dx minus u dv dx divided by v squared. So that's just another way of using notation to write down quotient rule. And third way of writing the quotient rule is y dash equals v u dash minus u v dash over v squared. So we used both of these in the same manner, but let's have a look at the example where we can use quotient rule. So I'm doing an example from exercise 9G, which is on page 322, and I'm doing question 1A. In question 1A, we have that y equals x over x plus 4. So in this instance, let u equals x, and when we derive this, du dx equals 1. And the next one is v equals x plus 4, dv dx equals 1. So combining both of these together into the quotient rule, substituting our u, du dx, v and dv dx, v is x plus 4 times 1 minus u is x, and du dx, dv dx is 1 over v squared, x plus 4 squared. This is x plus 4 minus x over x squared plus 8x plus 16. And here we can see that x and x cancel each other out, so we are left with 4 divided by x squared plus 8x plus 16. Now, you didn't even have to expand this bracket. We could have left this easily as 4 over x plus 4 squared. Alright, so this concludes the lesson. If you have any questions, let me know. I'll make sure to answer them, and I will give you the homework. Alright, for homework, exercise 9F, questions 2, 5, 7, 9, and 9G, questions 1, CFH, 2, ADE, and 3, AB. If you have any questions, let me know. Send me the inquiry directly via the email or on Edmodo, and I'll get back to you as soon as I am able to. Have fun and see you in the class.